Good morning all, my name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about problem solving on complement representation. So, how we are representing the complements. So, complement is nothing but, suppose binary number 0, what is the complement of 0 is nothing but 1. Suppose binary number is 1, what is the complement of 1? That is 0. So complement means we are applying 1's complement or 2's complement like this. But the complement means we are applying 1's complement, that is called complement. 1's complement, that is also called complement. Suppose complement of A. Complement A, that means A bar. Complement of A bar, that means A. So opposite value we are taking that for input value. So complements are used to simplify the subtraction operation and for logical manipulation. So what are the types of complements? Radix complement, diminished radix complement. So most probably complements are using for arithmetic subtraction. So to simplify addition, subtraction, multiplication, division also, but most probably we are using for subtraction, and logical manipulation also we are using complements. So there are two types are there, radix and diminished radix. So we will discuss each one. So 1's complement of binary number 0, that means 1. So 1's complement of binary number 1 means 0. Complement of A, that means A bar. Complement of B means B bar. So complement of A bar means A, like this. So we are complementing the input. So 1's complement of binary numbers. There are so many types of complements: 1's complement, 2's complement, 9's complement, 10's complement. But any of the complement majorly using for subtraction. So 1's complement of a binary number, that results when changes all 1's to 0's and 0's to 1's. So when we are performing 1's complement of the binary number 1011, is it binary? Yes, it is a binary. So what is the 1's complement of this binary number? So 1's complement of this binary number, the results will be changed to 1's to 0's and 0's to 1's. So 1's to 0's means here it is 1, yes, it is 1, it is converting to the 0. So 1's to 0's, 0's to 1's. Here 0, it will convert to 1. Here input is 1, convert to 0. Input is 1, convert to 0. So 1's complement of 1011, what is the output result value is 0100. So 1's complement of 1011, the result after the completion of 1's complement, the value is 0100. So it is one example of complement. So find 1's complement of 1101 base 2. So 1101 base 2. Base 2 means it is a binary number. Already defined, it is a binary number. So 1's complement is using for only for the given binary numbers. If your number systems are there, it is not possible. So these number system converting to the binary, then only we have to perform complement. So 1101, it is a binary number. So for this binary number, we are changing, in place of 1 we are taking 0, in place of 0 we are taking 1. So in place of 1 the value is 0, in place of 1 the value is 0, in place of 0 1 1 0. So the input value 1101, after the completion of 1's complement, what is the value now? 0010 base 2. So another one, find the 1's complement of 1011 1001 1011 1001 1001. So it is the base 2. Base 2 means when the number is binary, then only it is possible to perform 1's complement. So 1's complement ones complement of the given number. In place of 1, we are taking 0, 1, in place of 1, 0, in place of 1, 0, in place of 1, 0, 0, 1, in place of 0, it is 1, in place of 1, it is 0. So 0, 1, 0, 0, 0, 0, 1, 0, base 2. So ones complement of 1, 0, 1, 1, 1, 0, 0, 1, the value is 0, 1, 0, 0, 0, 0, 1, 0. So it is a complement. 1, 0, 1, 1, 0, 1, 0, 0. In place of 0, it is 1, like this. Okay. So in place of 0, it is 1. In place of 0, it is 1. So 1, 0, 0, 1. If it is 1, it is 0. If it is 1, it is 0. If it is 1, it is taking 0. 0 means it is 1. 0 means it is 1. Here 1, it is 0. So 0, 1, 0, 0, 0, 1, 1, 0, base 2. 2's complement. 2's complement of a binary number, the resultant when add 1 to the 1's complement. So 2's complement formula. What is 2's complement is equal to 1's complement plus 1. So what we are doing, the complement of the input value, after getting the 1's complement result, we are adding plus 1 to that one. Previously we discussed here what is the 1's complement. After completion of 1's complement, we are adding plus 1 to that 1's complement, that is called 2's complement. Find the 2's complement of 1, 1, 0, 1, base 2. Suppose I am taking here 1, 1, 0, 1, base 2. First we have to convert to 1's complement, then add to 1. So first I will perform 1's complement. In place of 1 I am taking 0, in place of 1 I am taking 0, in place of 0 I am taking 1, in place of 1 I am taking 0. So 0, 0, 1, 0. Okay. Is it 1's complement? Yes, it is a 1's complement. But what is the process now? After getting the 1's complement, we are adding plus 1. Where we are adding plus 1? We are adding plus 1 to the LSB value. It is MSB and it is a LSB. Least significant bit value, we are adding 1 to this. So 0 plus 1, 1. 1 is as is 0, 0. So 0, 0, 1, 1, base 2 is the 2's complement of the 1, 1, 0, 1. Next, another example. Find the 2's complement of 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, 1. Okay. I am performing 1's complement. So I am performing 1's complement for this. In place of 1, I am taking 0. In place of 0, 1. In place of 1, 0. In place of 1, 0. In place of 1, 0. 1, 1, 0. So what is the value? 0, 1, 0, 0, 0, 1, 0. We are adding plus 1 to the LSB. Least significant bit I am adding 1. 0 plus 1, 1. Here 1 as is 1, 0, 0, 0, 1, 0. So it is the final value 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 0, 1, 1. It is the 2's complement of the input binary number. And 1's complement subtraction. How we are performing subtraction with help of 1's complement. So subtraction of smaller numbers from larger numbers, subtraction from larger numbers from smaller numbers. So we are doing subtraction, but how many types are there? There are 2 types of subtractions are there. Two types of subtractions. Subtraction of smaller number from larger number. Subtraction from larger number from smaller number. So first I am taking smaller number from larger number. It is a larger number? Yes, larger number. I am removing from larger number to smaller number. 0 1 1 0. Is it small number? Yes. So larger number to smaller number I am subtracting. So larger number to smaller number I am subtracting. Here subtraction of larger number from smaller number. It is a smaller number and it is a larger number. So we are subtracting from the smaller number to larger number. So how we are performing? Larger to smaller means there is nothing a problem, nothing an issue. But smaller to larger, in a binary number, it is very difficult. For these difficulties, we are performing ones complement. We are applying ones complement and two's complement to the subtraction. So how we are performing ones complement subtraction in the smaller from larger? Determine ones complement of the smaller number. Add the ones complement to the larger number, remove the carry and add it to the resultant and end around carry. So I am taking one example. Smaller from larger. Smaller from larger. Is it larger? Yes. From larger to smaller means 0 1 1 0. Okay. It is a smaller, is there? Yes, smaller. So, what is the rule? First step, determine ones complement of the smaller number. We are performing ones complement to the smaller number. So, that is called, it is the subtractor and it is the subtrahend. Subtractor and subtrahend. So, from the subtrahend, we are performing ones complement to the subtrahend. In other words, it is also called smaller number. Subtracting smaller number or performing ones complement to the smaller number. Performing ones complement to the subtrahend. So determine ones complement of the smaller number or subtrahend. Anything. Okay. So we are performing ones complement to the subtrahend or smaller number. Next, add the ones complement to the larger number. So after completion of this ones complement of the smaller number, what is the result value? This result value. Result means after performing the ones complement, what is the value? This value is adding to this. This value adding to this and remove the carry and add it to the result. So what is the carry will come? Suppose the input is 4 digits are there. If I am getting any 5 digits, means the last digit is a carry. This carry we have to remove and we have to add it to the LSB. So we will discuss with one example, this one. So here I am taking subtraction. Subtract the following using ones complement 10 10 11 from means from this we are removing this. So from means we are taking first 111 001 111 001 from this one to this 10 10 11 10 10 11 10 10 11. So what we have to do, what is the rule here? We can study again. Determine the ones complement of the smaller number or subtrahend. What is the smaller number here? It is a smaller number. So we have to perform ones complement to this one. So what is the ones complement of this? So we can do what is the ones complement here? In place of 1, what I have to take? In place of 1, I am taking 0. In place of 0, I am taking 1. In place of 1, 0. In place of 0 1, in place of 1 0, in place of 1 0. Okay, 0 1 0 1 00. Okay, 0 1 0 1 00. Is it completed? Yes, the ones complement of this is completed. What is the next step? This one plus ones complement of this one. So subtractor plus two's complement of the value, result value 0 1 0, 1, 0, 0. We are adding this one. 1 plus 0, 1. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, 10. Here carry is 0. 1 plus 0 plus 1. That means 1 plus 0, 1. 1 plus 1, 10. 0 and carry. So what is the carry now? Here 1, 0, 0, 1, 1, 0, 1. Here how many digits are there? Here 1, 2, 3, 4, 5, 6 digits we got. Here also 1, 2, 3, 4, 5, 6. What is the seventh value here? Carry. This carry we are adding to the LSB. This carry we are adding to the LSB. So how can we add? Here we can see now 1, 0, 0, 1, 1, 0, 1. This carry I am keeping here in the LSB. So this one now removed. Why? Because I added to here. So 0, 0, 1, 0, 1. How many digits now? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, now balanced. This carry is added into the LSB. 1 plus 1, 10, 0 and 1. 0 plus 1, 1, 1, 1, 0, 0. So what is the now? 0, 0, 0, 0, 3, 1, 0. So it is the 2's complement of the result. Okay, it is about the 2's complement. Perform 1's complement for the following number 5. So in the binary number, what is the 5 value here? 2 2s are 4 here, 2 1s are 0, 2 0s are 1. Okay, so here what is the value now? 0 1 0 1. Is it binary? Yes. Binary representation of 5 is 0 1 0 1. Okay, but here what is asking? What is the 1's complement of the 5 value? But in the complement of anything, 1's, 2's, 9's, 10's complement, binary representation only it will be possible, not in the number system. So what we have to do? This number system we are converting to the binary, then only we are performing 1's complement to the result value in the binary form. So 0 1 0 1 is a binary representation of the value 5. Now we are performing 1's complement to this one. This in place of 0 it is 1, in place of 1 it is 0, in place of 0 it is 1, in place of 1 it is 0. So what is the 1's complement of 5? Means 0 1 0 1 is the value 5. We are converted to the 1's complement. What is the result value? 1 0 1 0 base 2. So 0 1 0 1 we are converted to 1 0 1 0. That is the 1's complement. So this 5 value we are doing 2's complement for this one. So 2's complement means 1's complement plus 1. So already we performed 1 0 1 0. That is a 1's complement. So 1 0 1 0. We are adding plus 1 to this one. That is called 2's complement. Where we are adding 1 means at the LSB we are adding plus 1. So 0 plus 1 1. 1 plus 1 0 1 1 0 1 is the answer. What is the input value? 0 1 0 1. It is the 2's complement. For 0 1 0 1, what is the 1's complement? 1 0 1 0. For after the getting the 1 0 0, what is the 2's complement? 1 0 1. Okay, so finally 0 1 0 1 is a binary representation, and what is the 1's complement means 1 0 1 0, and of what is the 2's complement for this one means 1 0 1. So binary 1's complement, 2's complement. Example of 1's complement. Subtract 1 0 1 0 base 2 from 1 1 1 1. So we are doing larger. We are doing from smaller from larger. Okay. So normal subtraction 1 1 1 1 1 0 1 0. So it is a 0 1 0 1. It is a normal subtraction or direct subtraction. But here it is asking example of 1's complement. So we are performing 1's complement to this subtracting value. So what is a smaller value here? It is a smaller value. We are performing 1's complement to the subtrahend. 1 1 1 1. What is the subtrahend value now? 1 0 1 0 means 1 0 1 0 means 0 1 0 1. So 0 1 0 1 is the 1's complement of 1 0 1 0. So 0 1 0 1 we are added 1 plus 1 0 and 10. 1 plus 0 plus 1 10. 0 and 1 1 plus 1 10 plus 1 11, 1 and 1. 1 plus 0 plus 1 means 10, 0 and 1 carry. This carry is added to here, LSB. So 0 plus 1, 1, 0, 1, 0. Okay. So it is a normal or direct subtraction. It is the ones complement. Both are same, but what is the method we are applying, that is important. 1 0 0 1. What is the ones complement? 0 1 1 0. Like this. If I are adding plus 1 to this one means 0 plus 1 1 1 0. It is the 2's complement and it is the 1's complement. Like this. 2's complement representation. 1 0 1 0 base 2 from 1 1 1 1. It is a subtractor and it is a subtrahend. So we are applying 2's complement to the subtrahend. So what is the process of 2's complement? 1's complement plus 1. So it is 1 1 1 1. It is a subtraction value. And what is the 1's complement? In place of 1 0 1 0 1 0 1 0 1 is the 1's complement. We are adding plus 1 0 1 0 1. We are adding plus 1 1 plus 1 10 0 plus 1 1 1 0 0 1 1 0 is the 2's complement. So subtraction value plus subtractor plus 2's complement of the subtrahend value. So what is the 2's complement of subtrahend means? 0 1 1 0. So we are adding both together. 1 plus 0 1, 1 plus 1 10, 1 plus 1 10 11 and 1 plus 1 10 like this. So it is a carry. So we are neglecting the carry because in the 2's complement when the carry will be there, we are neglecting this one. But if it is 1's complement, this carry is added to here. But when 1's complement, but in the 2's complement we are not adding carry, we are removing this carry. We are neglecting this carry. And very important one, 9's complement representation. It is also using for mostly for subtraction. It is to subtracting each digit in the number from 9. So what are the number systems are there? From the number systems, we are subtracting 9 from the number. That is called 9's complement. Suppose my input value is 0. What is the 9's complement of this one means? 9. Suppose my input value is 1. What is the 9's complement is? 8. How it is possible means? 9's complement is there now. So I am taking 9. What is the input value here? 9 minus 1. What is the value? 8. So 9's complement of 1 equal to 8. I am taking 9 here. Why? Because it is 9's complement. What is the 3 value? 9 minus 3. 9 minus 3. How much now? 6. I am taking here one example 7. 9 minus 7. What is the value now? 2. Here 9 minus 9. What is the value? 0. So we are subtracting from the original digital values. Those values are called 9's complement. Suppose 9's complement of 5. So what is a 5? 9 minus 5. That means 4. So 9's complement of 5 equal to 4. Okay, like this. Determine 9's complement of the smaller number. Add the 9's complement to the larger number. Remove the carry and it to the result. So it is the smaller from larger values. Smaller from larger. That means larger minus smaller. So determine the 9's complement of the smaller value. That is the subtrahend. Subtrahend value. Add the 9's complement to the larger number. This larger number, after getting the 9's complement of this one, we are adding both together and remove the carry. If any carry will become, we are neglecting that one. And end around carry. End around carry means that carry will add it to the LSB. Example 1. Regular subtraction. 8 minus 2. How much? 6. But here 9's complement of 2. That means here 8 minus 2. How much now? 7. But here, what is a subtractor? What is a subtrahend? Okay, it is a larger number and it is a smaller number. So what is our rule? Determine the 9's complement of the smaller number. So what is the 9's complement of 2? In the table, we know that what is the 9's complement of 2? That is called 7. Why? Because 9 minus 2, 7. Okay. So 9 minus 2, it is 7. 8 complement of 2, that is 7. 8, we are adding 8 plus 7. How much? 15. but here one digit, but I got 2 digit. That is called, it is the carry. So I am removing this carry, I am adding to the this one. 5 plus 1 now 6. What is a regular subtraction? 8 minus 2 6. 9's complement also I am getting 6. So subtract 13 from 28 using 9's complement. It is one example. Subtract 13 from 28. 13 from 28. From 28. 8 minus 3 5. 2 minus 1 1. So I want to get 15. So how it is possible? 28 minus 13. So what is a smaller value here? It is a smaller value. We are applying 9's complement to the smaller number. So what is the 9's complement of smaller number? I am taking how many digits now? 2 digits. So 99. So 13, 99. 9 minus 3, 6. 9 minus 1, 9 minus 1, 8. So what is the value? 86. So this one plus this one, 86. 8 plus 6, 8 plus 6, 14. 8 plus 1, 9 plus 2, 11. It is a 2 digit value, but I got a 3. That means it is a carry. So this carry removed and added to this one. 4 plus 1, 5 and as this one. So we are removed this carry and added to the LSB. So 13 minus 28 using 9's complement. What is the value now? 15. So 28 minus 13. It is a 15 normal subtraction. But here, what is the subtrahend? Smaller value here 13. So I applied 9's complement to the 13. So 2 digits are there. That is the reason I am taking 2 9's are there. 99 minus 13. So it is the 86. So 28 plus 86. 114. Last digit is the carry. This carry I am removed. I am added to the LSB. 14 plus 1, 15. So both are same. Yes. Next, 9's complement of the large number. So it is the larger from smaller. Larger from smaller means we are 9's complement to the larger number and add a 9's complement to the smaller, and resultant will get. Small number is to be subtracted from larger. Suppose regular subtraction 678 minus 234. What is that means? 344. Here 678 is a common now 9's complement, but 9's complement of 234. 9's complement of 234. What is the value? 234. Adding 999 minus 234. 9 minus 4, 5. 9 minus 3, 6. 9 minus 2, 7. So I am taking 765. 678 plus 765. How much? 1443. Here 3 digit input, but I got 4 digit. That means last two is the carry value. This carry is added to the LSB of the value. 443 plus 1. What is? 344. So both are same as it is a normal subtraction and it is a 9's complement. It is the larger number is to be subtracted. Reverse order. Here 678 minus 234. Larger minus smaller. Here smaller minus larger. So 228 minus 485. What is the value? Minus 257. So it is a normal subtraction. But here I am using 9's complement. So 228 is as it is. 485. 999 minus 485. 9 minus 5. 4. 9 minus 8. 1. 9 minus 4. 5. So 514. 228 plus 514. 8 plus 4. 12. 2 plus 1. 3 plus 1. 4. 5 plus 2. 742. So these are both same. No, why? Because it is a negative representation. It is a positive representation. So again we are performing 9's complement to the 742. Again 9's complement to the 742. 9 minus 2, 7. 9 minus 4, 5. 9 minus 7, 2. So what is the now value? Minus 257 after the 9's complement result. So what is the difference means? It is we are not adding again to the 9's complement. Why? Because larger to smaller. But here smaller to larger. So smaller minus larger. Smaller minus larger. When we getting the negative value. When we getting the negative value of the result. Again 9's complement we are performing after getting the result. That is called 9's complement. Next, 10's complement of a decimal number. The results when add 1 to the 9's complement. So 10's complement equal to 9's complement plus 1. determine tens complement of the smaller number, add tens complement to the larger number, and discard the carry. So first determine the smaller from larger, larger minus smaller. So tens complement of the smaller number, add tens complement to the larger number, add tens complement to the larger number. So after getting this, after completion of tens complement of this smaller, larger plus tens complement, and discard the carry. If any carry we are neglecting or we are discarding, we are not adding. Why? Because in the nines complement we are adding carry to the LSB, but in the tens complement we are not adding carry to the LSB. We are removing or discarding the carry. Example: perform tens complement for the number 8. So for the number 8, but here what is a regular subtraction? 8 minus 2. How much now? Sorry, 8 minus 2, 6. It is a normal, but when I applying the tens complement, means what is the nines complement of 2? 9 minus 2. How much? 7. Okay, but here tens complement means nines complement plus 1. That means 8. So 7 is the nines complement. So what is the tens complement equal to? Nines complement plus 1. So 9 minus 2, 7, that is called the nines complement, plus 1, that is the 8. So 8 is the value, 8 plus 8, subtractor and tens complement of subtrahend, 8 plus 8, 16. So this one value we are neglecting. Why? Because in the tens complement the carry is discarding. So that is called 6, discard the value. Okay, it is the tens complement of the 8 minus 2. Determine the larger from smaller, that is smaller minus larger. Determine the tens complement of the larger number. Determine the tens complement of the larger. Add the tens complement value. What is the tens complement value? We are adding to the smaller, and take a tens complement of the result, assigning the negative sign. If any negative sign, we are assigning to this one. When smaller number is to be subtracted from larger, 678 minus 234, that is a 444. When applying the tens complement, 678 is common, minus 234, we are applying nines complement to the 234. 9 minus 4, 5, 9 minus 3, 6, 9 minus 2, 7, 765 plus 1, that is a 766. It is a tens complement. It is a nines complement. For nines complement plus 1, tens complement. So 678 plus 766, 8 plus 6, 14, 7 plus 6 plus 1, 14, and 6 plus 7 plus carry 1. So 1, 444. This one I am removing. So 444. Here smaller minus larger. So it is a smaller minus larger means definitely we will get the negative value. But in the nines complement, what is the process? So 228 minus 485 is there. So this 485, we are performing nines complement of this one. 9 minus 5, 4, 9 minus 8, 1, 9 minus 4, 5, 514 plus 1. What is the value? 515. So 228 plus 515, that is a 743. So 7 again tens complement this value, 743. Again tens complement. That means 9 minus 3, 6, 9 minus 4, 5, 9 minus 7, 2, 256 plus 1, 257, negative representation. These are the references. So in the today discussion we completed what is the complement representation. So complements are using for subtraction operation and logical manipulation. What are the types of complements are there? Radix complement, diminished radix complement, and once complement is performing, what are the steps means ones to zeros and zeros to ones. That is a process, and we are example here taking find the ones complement of 10, 11, 100, 1. It is a process getting the ones complement. Next, twos complement equal to ones complement plus 1. So ones complement types. subtraction of smaller number from larger number, subtraction of larger number from smaller number. And if you are going for the smaller from larger, that means larger minus smaller. So what is the process means? Apply the ones complement to the smaller number, and after getting the result of ones complement value, we are adding this value to the subtractor, and what is the value? That is the final. If any carry will be there, we are adding to the LSB. So it is a one example of ones complement of subtraction. Perform ones complement for the number 5. So we are adding 5 converted to the binary, again performed ones complement, again performed twos complement. Here the normal subtraction, direct subtraction with ones complement. Here direct subtraction with twos complement method. Here it is a nines complement table for subtraction. Here nines complement types: smaller from larger, larger from smaller. So what is the process for smaller from larger? Determine nines complement of smaller number, add nines complement to the larger, remove the carry and add into the result, end around carry. Regular subtraction, nines complement subtraction. 8 minus 2, 6. That is the normal subtraction. And we are going for the nines complement, means for this to subtractor or smaller value, they are applying nines complement for this one. So what is the nines complement means? 9 minus 2, how much? 7. So 8 plus 7, 15. This carry is adding to this one. 5 plus 1, 6. So larger from smaller. Determine the nines complement of the larger. Add nines complement to the smaller number. Take nines complement to the resultant and assign negative sign. And it is a number system. Subtraction from larger one. So 678 minus 234. So it is a 228 minus 485. So it is a tens complement from larger to smaller and smaller to larger. And tens complement equal to nines complement plus 1. So these are the two types: smaller from larger, larger from smaller. So determine tens complement of the smaller number, add tens complement to the larger number and discard the carry. Perform tens complement for the number 8. Determine tens complement of the larger number, add tens complement to the smaller number, take tens complement of the result and assign negative. So it is a smaller number to be subtracted from larger one using tens complement, and it is the larger from small subtracted from smaller using tens complement. It is a process of complement representation. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.